This is page 55 from your packet from May 12th, and it's basically taking a look at the number of different combinations of people, you know, like committees and things like that that you can create from a pool of people. And the first thing you have to determine is whether it's a combination, because a combination order doesn't matter, or a permutation. A permutation order does matter. For instance, on number 2, if you read it, it says a committee of 3 is to be chosen from 6 people. Well, that order doesn't matter. Everyone's just on the committee. Whereas on number 1, it's saying that it's composed of a president, vice president, and treasurer. In this one, order does matter because the duties and responsibilities of each of those offices would be different. So here, order matters. And on number 2, order does not matter. And so you have to know which one is which and what to call that to be able to work these problems out. So what I want to show you is a really fun picture. Okay. You may not remember this. If you're too young to remember 80s hair, bless your heart, it was lots of fun, but I literally went to high school with girls that looked like this, with giant big hair. Okay, these wings that they would make do like that, that was very important. And this was called a poof. Oh, so nice. So anyway, but if you don't know what this comes from, let me show you. Most of that hair came from something called a permanent. Now here's what a permanent is. This stuff is basically like very weak Nair, the hair removal. It's in fact exactly the same chemical. It's just weakened, you know, kind of diluted a little bit. What it does is takes the hair, burns it, and makes it weak and brittle, which if you do that while it's wrapped up in a roller, it'll keep that shape. So this is a permanent. Now this is the Nair stuff. Okay. It's called gentle straightener lotion. It was anything but gentle, burned like all get out. Okay. This right here is neutralizer. This is a chemical which binds with the burning chemical in Nair to stop your hair. So this stops the acid. It stops your hair from being completely burned off of your head. And then the last thing is a conditioner, just to do your best to mitigate some of the damage. Okay, these chemicals were done in a particular order. If you put the neutralizer on first and then did the Nair lotion on your hair, you would burn your hair off, or you would have so much neutralizer that the Nair stuff would not work and would not make a permanent happen for you. Okay, so here's how to remember. Permutation, order definitely matters, the same as a perm. All right, so you can thank all of these beauties for how you're going to remember that. So if you're looking at this, a committee is composed of a president, vice president, and treasurer. Order matters, same as a perm. So this is a permutation. On your paper, you would write it this way. This is the symbolism to show this. 6 people are trying out for 3 positions. So you would say 6P3, which means of 6 people, permutation with 3. All right. For the one that order doesn't matter, that is a combination. Okay. And so a committee of 3 is chosen from 6. That means you've got 6, you're choosing 3, and that is a combination. Now, there is a way to calculate this, and I can show you. I'll show you just theoretically on both of these, but your calculator will do this for you. If you can get it to this point and this point, your calculator for the assessment will do that. But I do want to show you sort of the theory about it. If you're choosing 3 slots, okay, from 6 people, that means for the very first slot, you actually have 6 different people to choose from. But once you've chosen that person, you have 5 people to choose from for the second slot, because one's already been allocated to the first slot. And for the final of the 3 positions, you only have 4 people to choose from. So it's really just fundamental counting principle And 6 times 5 times 4, I can do that in my head. Hold on. Go back. Not email. Sorry, I get confused. It's late in the day. All right. 6 times 5 is 30 times 4. That's 120. Okay. This is how many possibilities there would be if order absolutely matters. Okay. So there were 6 people, but that you only got to choose from them for that very first position. The next one's very similar. A committee of 3 is chosen from 6. So it's still on the top, 6 times 5 times 4. Okay, so you've got a numerator 120. But what you have to divide by is the number of different ways that you could order 3 numbers. If that makes sense. So here's like, if you have 3 numbers, 1, 2, 3, and you're going to put them in order. For the first one you have 3 choices. For the second one you have 2 choices. And for the third one you only have 1 choice. So there are actually 3 times 2 times 1. There's 6 different ways you can order 3 people. Okay, so you would divide this by that, by 3 times 2 times 1. And so divide 120 by 6. If order doesn't matter, there are actually only 20 committees that you could make, because the order that you say their names doesn't matter on just a plain old committee. So let me show you how your calculator does that. By the way, I don't know if you remember factorials, but we'll go back to that another time. If you have your calculator and you go down to, I believe it's number, it is, okay? If I was doing number 1, permutation, you click the NPR button and it asks you how many do you have to choose from first. So you're going to say 6. You have to put a semicolon in between these. And then it says how many are you choosing, and that's 3. From 6, choose 3 and enter. And that gives you 120. Okay? For combination, you click NCR, from 6, semicolon, 3, enter. And you choose that, and it's 20. Okay? So all of these are quite easy to work out with just your calculator. So looking at this one, number 3, move this down, it will go. Oh, sorry. A committee is composed of a president, a vice president, and a treasurer. Okay? If 5 people are running for president, 6 are running for vice president, and 3 are running for treasurer, how many unique committees result? And so this is how you work this out. You go, okay, this has to be a president, and there are 5 people running for that. This has to be a vice president, and 6 people are running for that. And this has to be a treasurer, and how many? 3 are running for that. All right. It doesn't matter, because this is of 5 people, you're choosing 1. And this one is of 6 people, you're choosing 1. And this one is of 3 people, you're choosing 1. It doesn't matter whether you do permutation or combination on this particular set of problems, and the reason is because you're only choosing 1. There's only 1 order that you can do these in. So you can enter this whole thing in your calculator like this. Math, number. Okay, you could say NPR of 5, semicolon 1. Come out here, outside there, times NPR 6, semicolon 1. Get outside the parentheses, times NPR 3, semicolon 1. Okay, and so all 3 of those, 5, 6, 3, that's okay. I want you to notice something, and I told y'all that this sometimes happens. Oh no, I see the error. I just hit the times more than once. Never mind. All right, so with the NPR, it gave us 90, and I just want to show you clear. NCR 5, semicolon 1 times NCR 6, semicolon 1 times NCR 3, semicolon 1. And that's also 90. Okay, so it really didn't matter, but the only reason it didn't matter was because you were only choosing one from each of those possibilities. So 90 is D. By the way, this one, 2 is A, and 1 was 120, or E, 120. Okay, so now look at this one, jousting. You've got these teams. It's got 2 knights and 2 squires. So here's knights, here's squires. It says they're forming a team from 5. So this is going to be 5. It's just a team, so order doesn't matter. So it's 5 in, well, this is how you're going to enter it. NCR, open parenthesis, of 5, semicolon, choose 2. And this is going to be NCR of 3, choose 2. Okay, and you're going to multiply those together, and that will tell you how many different, okay, NCR, how many different teams you could have. 5 semicolon 2 times NCR 3 semicolon 2. That's 30. Answer is D. And the last one, a septet, has 7 players, 1, 2, 3, 4, 5, 6, 7. It's made up of 4 strings, so this side is strings, and 3 woodwinds. Okay, 7 students. So this is for try out for strings, and it does not, well, let me put it the way you're going to enter it. You're going to enter NCR. If it said something like that, which chair they were in, first chair, second chair, third chair, then you'd use P for permutation, but it doesn't matter. It's just saying that of the 7, you're choosing 4, and here for the woodwinds, 7 strings, 7 woodwinds, there's also 7, but you're only choosing 3 for that. And you're going to multiply those two together, and so that will give you math number NCR 7 semicolon 4 times NCR 7 semicolon 3. Enter. And that's 1,225, which is answer E. And that's it.